So in this video, I'm going to go over the two examples that you did for this week and show you the solutions to those. And then I'm going to show you one other worked example, and I'll show you it isn't a one-to-one ratio, so it'll be another example where we haven't got that one-to-one ratio. And then I'll show you a couple of ways that that could be set differently. And then hopefully by going through these, you'll get a good understanding of what these calculations are about. And then from that, I'll leave you with 3 or 4 more to try. So these were on page 20. So the top one was, what mass of carbon dioxide can be produced from 3 grams of carbon? So first thing, as we said to do, is look at your equation and then get the ratio of it. Now you remember how we get that. So we look at the balanced equation, and you can see there's no numbers in front of each of those. So you're assuming one of those reacts with one of those to produce one of those. So there's our ratio 1:1. Now, where some of you went wrong, look at what you're given in the question, first of all. Now, you're told there's 3 grams of carbon. So there's what you can work out the number of moles of. So we're going to go over here. We're going to start with 3 grams of this. So work out the number of moles, use N equals M over RFM. So 3, when you look up your periodic table, 1 mole of carbon is 12. So that's why we put 12 on the bottom line there. And then 3 over 12 is 1/4 of a mole, or 0.25. Now, what we're asked is what mass of carbon dioxide can be produced. So we're going to go from the carbon over to here, the carbon dioxide. So the ratio is 1:1. So we'll put that in. So we're going from the carbon over the carbon dioxide. Ratio of carbon to carbon dioxide is 1:1. Now, what we'd worked out here was with 0.25 moles. So 0.25 moles of carbon produces 0.25 moles of carbon dioxide. And then what we need to get is the mass of that carbon dioxide. So up here at the top, you'll see we've worked out CO2, 12 for carbon, oxygen 16 multiplied by 2. So 1 mole of carbon dioxide is 44. So then the mass of 0.25 mole, this is going to be 44 times 0.25, which gives us 11 grams. And good to see lots of you getting that. Question 2, what mass of hydrogen gas is produced from 12 grams of magnesium? So again, we'll look at our ratio, but first of all, before we do look up the question here, we're going to be starting here. There's the information given, 12 grams of magnesium. So our ratios will come down to our equation. So again, these are all 1:1. There's no numbers in front of this to balance it. So one of these reacts with one of these to produce one of these and one of these. So our ratio is 1:1 to 1:1. Now, we've got from the question 12 grams of magnesium. So let's work out the number of moles. N equals M over RFM. 12 was the figure we're given up here. If we look up our periodic table, magnesium is 24. So 12 over 24, 0.5 mole. Now, what we're asked to work out is the mass of hydrogen gas. So we're going to go from the magnesium over to here, the hydrogen. So from there to there. So we know, looking at our ratios, again, it's 1:1. Magnesium to hydrogen is 1:1. So for every 1 magnesium, we produce 1 H2. We know from here that we have 0.5 mole. So 0.5 mole of magnesium produces 0.5 mole of H2. And then we need to work out the mass of that. So mass of H2, well, hydrogen's 1 multiplied by 2, 2. So 1 mole of hydrogen equals 2. So therefore 0.5 mole is going to be 0.5 times 2, which works out at 1 gram. And again, good to see lots of you getting that figure. So the worked example that we have in the worksheet is this. So I'll work through this with you. And again, you see it's done exactly the same way as we've done with the previous two. So first of all, let's look at our equation and get our ratios. So we can see this time there are numbers in front to balance it. So K plus O2 gives us K2O. So there were 2 oxygens here, so we had to put a 2 in front of it to give us the balancing up the oxygens. That means there's a total of 2 times 2, 4 potassiums. So we put a 4 there. Now, what that really means is for every 4 K atoms, for every 4 atoms of potassium, you react with 1 oxygen, O2. There's no number in front of that, so there's 1 O2. And that gives us 2 K2O. So 4 to 1 to 2. So our ratios, 4, 1, 2. So for every 4 of these, you need 1 of these, and that'll produce 2 of those. Now, the question says that we're starting with 0.75 grams of potassium, and it asks us what mass of potassium oxide? So the reason I set out with these columns is that's so you can visually see that we're going to go from the amount of potassium, that's what we're going to work out in a moment, is how much potassium we've got, and we're going to try and work out how much K2O is produced. So we're going to scale between these two columns. All right, we're going to scale from potassium right across to potassium oxide. So you'll see when the ratio comes, there's the ratio that we need, the 4:2 ratio, which we usually simplify down to a 2:1 ratio. So let's work out first of all the number of moles. Now we're told 0.975 grams of potassium. So N equals M over R FM. Divide the 0.7 at 975 by 39. If we look at potassium periodic table, it's got an atomic mass of 39. And that works out at 0.025 moles, or 1/40th if you do it as a fraction. Now, as we said at the start, we're going to scale from this column across this one. So our ratio is 4:2. So for every potassium, for every K, 4 per K, we produce 2 K2O, 4:2. And that's usually simplified down to a 2:1 ratio in your head. You'll be able to see that's a 2:1 ratio. So in other words, for every 2 of those, we produce one of these. For every 2 potassium, we produce 1 K2O. So we know from the question with 0.025 moles of potassium. So to work out the number of moles of K2O, divide that by 2. For every 2 of those, reduce 1 of those. So 0.025 divided by 2, and that works out at 0.0125 mole of K2O. Now the mass of 1 mole, go up there, K2O. So potassium's 39 multiplied by 2, oxygen 16, 94. So 1 mole of K2O is 94. Then work out the mass of 0.0125 mole of this. So 0.0125 times 94 gives us 1.175 grams. So there's an example where it's not necessarily a 1:2 ratio. That's a real reminder of that type of one. Now, just to show you, you have to look with these questions at what you've been given and what you're asked for. So I'll give you 2 other ways. Now I haven't got it on the worksheet, but you can follow this on the video, and I'll show you 2 other ways this question could have asked. You could have asked the same question in a slightly different way about the same reaction. So look at this. So suppose this time they said, what mass of oxygen is needed to react with 0.975 grams of potassium? Now if you look back at the previous question, do you remember what we had with it? Was we had what mass of potassium oxide. So this original one was going from potassium, told you potassium, and they wanted to know how much of this was produced. Now this one is the same thing. You've 0.975 grams of potassium, so we're going to start the same way, but this time we're asked how much oxygen is needed. So this time there's a ratio 4:1:2. But this time, we're going to scale between these 2 columns. You're told how much potassium, so we're going to start here, and you'll see it'll start exactly the same way as the last time. But this time, we need to work out how much oxygen, 4:1 ratio. So for every 4 K, we only need 1 oxygen. So there's our number of moles of potassium, exactly the same as we did in the last time, 0.975 divided by 39, 0.025. But this time the ratio is 4:1. For every 4 potassiums, we only need 1 O2. So we're going to scale between those 2 columns. And then K, so for every 0.025 moles, we're going to need 1 of those. For every 4 of those, we need 1. So to work out the amount of oxygen, 0.025 mole of potassium is going to be 0.025 divided by 4 moles of O2. 4 down to 1. So the 0.025 moles, what we had here, divide that by 4. And that is 0.00625 mole of O2. And then finally, to work out the mass, 1 mole of O2 is 32. So multiply the 32 by 0.00625, and that gives us 0.2 grams. So you can see it's a similar question. It starts off exactly the same, but this time it asks the amount of oxygen. Now, another way that question could be asked is this. What mass of potassium is needed to react with 3.2 grams of oxygen? So again, it's based on the same equation, therefore the same ratios, 4:1:2. But this time, what we're given is we're given the mass of oxygen. So we're going to again scale between those 2 columns, but this time it's going to be from this one over to this one. For every one of these, we'll work out how much oxygen we've got, and for every one of those, we'll get 4K. So work out our number of moles. So 3.2 grams of oxygen, so divide the 3.2 by O2, 16 times 2 is 32. So that means 0.1 mole. Now this time, because we're going from 1 mole of this to 4 mole of this, we'd go from 0.1 up to 0.4. So we'll scale across there, 1 to 4 ratio. So for every 0.1 mole of O2, it'll be 0.1 times 4 mole of potassium, 0.4 mole of K. And then to finish off the calculation, 1 mole of K is 39, so potassium by itself weighs 39, and then that means 0.4 mole is going to be 0.4 times 39, 15.6. So if you're happy enough with those, then on the worksheet that I've provided, there are 4 examples. And again, lots of them are 1-to-1 ratios, because when you come to your GCSE questions, the vast majority, as you'll see, will be 1-to-1 ratios. But we'll also include, for example, there's sodium reacting with oxygen, which isn't a 1-to-1 ratio. So you're going to have an example or 2 there where it's not a 1-to-1 ratio. So have we got those? Photograph how you get on with those, and I'll look at it and give you some feedback on that.